Alrighty, sports fans, here we go. Time for review. Okay. Make sure you are showing all your work. That's really the key to this whole one here. And I apologize on these first ones. I didn't set it up in the program to give you a whole lot of room. So let's go ahead and copy this equation down over here so you can show some more room. Every time you solve an equation, I want you to think about where's that variable and how am I going to get it isolated, get it by itself. Here's why. I'm subtracting this number. So to counteract that operation, I'm going to use the inverse operation, which is adding. These two are opposites and they counteract each other. They go to 0, and y plus 0 is y. You have to be fair and do the same thing over here. Now, on this one, I have said that a calculator is allowed. You can either do it by hand or use a calculator. Go ahead, I get 26 and 1/10. Aha, ooh, careful. Trying to mislead you there a little bit, so make sure you are watching your positive and negative signs. Next, number 2. Again, not enough room here, so I'm going to rewrite this equation over here. Negative 1 7/10 p is 3 4/10. This is understood as multiplying, okay? And so I need to undo that with division. Go ahead and divide both sides and make sure you divide by negative 1.7. Negative 1.7. Negative over negative is positive. 1 7/10 divided by itself is 1. 1 times p divided by 1 is p. You can either use your calculator or you might be able to recognize that 34 and 17, they're exactly half of each other. So 3.14 divided by 1.7 is 2, but it's going to be negative 2. D. Number 3, aha, this is a 2-step equation. I'm going to rewrite this just so I can give myself a little more room. All right, I've got to get the variable y by itself, and I have 2 things going on here. I multiply by 3, and then I'm subtracting 12. So you have to go in the reverse order. The first thing we're going to counter with is the subtracting of 12. And you do that by adding, okay? So here we go. Add 12, add 12. These go away. Here's 96. All right. When you divide by 3, divide by 3. These go to a 1. And I get y equals 32. Yoo-hoo! There it is right there at letter A. Okay. All right, now we are done with this part, and now we are moving on into just work it out. No more multiple choice. So here we go. Number 4, get x by itself. You have to counteract adding 26. Do that by subtracting. Make sure you do it on each side of the equation to keep things fair and balanced. These counteract each other and go to 0. X plus 0 is x. Negative 13 minus 26, think. You're already at negative 13, and then you're subtracting more. So you're going further into negative land, and you should end up with this. You've got a calculator, check it out. Plug in negative 39 and add 26. When you do that, see what you come up with for an answer. Aha, yes, that's what you started with. There you go. All right, next one. Here's my variable y. I need to combat or counteract that subtracting of 16 and 8/10. Do that with its inverse operation, which is addition. Whew. Yay, hooray, that goes away. I get 22 and 5/10. Okay. Check your answer to make sure it works. You can just do it on your calculator. You don't have to show it to me. Okay. But plug in your answer and subtract 16 and 8/10. Press the happy equals or enter button, and ta-ding, you should get 5.7. Great. Turn the page. Here we go. We're on a roll now. Fractions, fear not. If we are going to get m by itself, we're going to have to subtract 5/6. Now, when I do that, and I look at this, these counteract each other, they're opposites, and they go to 0. And m plus 0 is m. On this side, here's what's happening. 5/9 minus 5/6. Now, stop and think for a second before you grab that calculator. 5/9, think of a pizza. You have 5 out of the 9 pieces. That's just barely over half. Okay? And then you're subtracting 5/6, which is almost a whole pizza. This is going to end you in negative land. Okay? If this isn't making sense to you, think about if we were doing this by hand, I would have you turn both of these into a common denominator. 5/9 becomes 10/18, 5/6 becomes 15/18, and you're subtracting. Aha, m is negative 5/18. Use your calculator to check it out, plug it back in, take negative 5/18 plus 5/6, boom, there's your answer. All right, next. I want to get m by itself. I need to counteract that multiplying by 3. So I'm going to divide by 3. 3 divided by 3 is 1. 1 times m over 1. That's just m. That's exactly what I wanted. But this side looks absolutely hideous because I created this gross compound fraction. This is what I'm asking you to do. Negative 6/11 divided by 3. If we were doing this by hand, you would think negative 6/11, instead of dividing by 3, that's the same as multiplying by its reciprocal, which is 1/3. And now, oh sweet, this is easy. I end up with m being equal to negative 2/11. Yes. Plug that in, see if it works. Yes, it does. Awesome. All right. Let's keep pressing on. All right, decimals. For me, decimals much less preferred than fractions. Here's m. I want to get it isolated, so I'm going to undo multiplying by division. Okay, show your work, show your work, show your work. Here we go. Divide, divide. I get 1m, or just m. You know, sometimes I write the 1, sometimes I don't. You can go either way. If you just put the variable m, that's fine. All right, now, go ahead and divide this. You know, if we were doing it by hand, we'd be doing something like this. Move the decimal point 2 spots. Have to add 2 spots and all this. And then I'm looking at this going, ugh. Okay? You get a final answer of 28, I believe. Okay? How is that possible? I just went and took 21, I divided by something, and I get an answer that's larger than what you started with? Oh, well, that's because when you go ahead and divide by this, it's less than 1. Dividing by something smaller than 1 is the same as multiplying by its reciprocal. The reciprocal would be bigger than 1. That's why. Cool. Check it, make sure it works. All right, now we got some two-steppers here. Here's x. You have to counteract the 3 and the 24, but you have to do it in the reverse order from your order of operations. See, if I plug a number in, I'd multiply, then add. Now we got to go in reverse. Undo the adding, then undo the multiplying. Subtract 24. Yay, hooray, that goes away. That's 0. On this side, you get negative 42. All right, keep going. One more step here. Divide by 3. Divide by 3. 3 divided by 3 is 1. 1 times x over 1 is x. This gives me negative 14. Boom chakalaka. There we go. Throw it in, check it, plug it in here. Yep, it works. All right, number 10, last one on this page. It's a two-step equation. I want to get x by itself. First, I'm going to counteract this plus 22, and I'm going to do that by subtracting 22. Okay, this goes to 0. That leaves me with negative 6x on the left. On the right, I have negative 12. This is not so bad. I don't even really need a calculator as long as you've got your positive negative skills down with your integers. All right, negative divided by negative is positive. 6 divided by 6 is 1. 1 times x over 1 is x. This is positive 2. Sweet. Check it, make sure it works. All right, coming in the home stretch. You have 2 word problems. No whining, okay? This is real life. This is the kind of stuff that happens, so we've got to apply it. I told you the other day, you have algebra eyes, algebra antenna, so as you look at things, you start thinking. All right, the bill from the auto mechanic was $667. Ouch. He charged $293 for the parts and $68 per hour for the labor for him to do the work. How many hours did the mechanic work repairing your car? Okay, so let's think about this in the big picture first, okay? You have the total bill is equal to the parts, there's charge for that, and then plus the parts for the labor, okay, the work. Those 2 together equaled 667. So let's make an equation. This is $667, the bill, right there. That equals the parts, which was, we know, $293. And then we're going to add in the cost for them to do the work, which is $68 for every hour. So I have to multiply this by however many hours that he worked. I don't know what that is, though. So I've got to use a variable. What do we want to use for hours? How about H? That makes sense, huh? Okay, well now it's a nice 2-step equation, just like the ones we've been doing. Okay, meow. My variable's here. I got to get rid of 293 first. So I'm going to subtract it because 293 and a minus 293 goes to 0. On this side, take 667 minus that 293, and you should get 374. Okay, let's see. Now I have to get rid of 68 or counteract that by division, because that's what undoes the multiplication. 68 over 68 is 1 over 1. What happens over here? Oh, you get 5.5 hours, 5 5/10. Now, hold on. Don't just leave your answer this way. Okay? How many hours? He worked 5.5 hours. He worked, I'll move this up a tad, 5 5/10 or 5.5 hours. There you go. One last one. We did one of these the other day when I had you going around the room and doing various word problems. So you and your friends, or a group of friends, go and get the huge bucket of popcorn at the movies. It costs $4.85 to buy it, and then 65 cents for every refill. Let R be the total number of refills, and T be the total cost. Write an equation that relates refills, R, to T, the total cost. Now, before you just want to say, ugh, there's too many words there, just stop, okay? The total amount of money that you spent, the total cost, is going to equal the first bucket that you buy, because you have to actually get the bucket, and then all of your refills. This is really what we're doing. We're taking the cost of the bucket and then all the refills. That's the total amount of money. Make sense? Okay, so now let's, instead of writing total cost, they're saying let T be that. The first bucket, I know how much that was. It was $4.85. Sweet. Plus, I've got a bunch of refills. I don't know how many refills we got, but I know they were 65 cents each. And how many did you get? Well, I don't know. So I have to multiply by R, however many refills you had. There's your equation. Okay? The total cost is $4.85 plus 65 cents times the refills. So now that you've got this set up, how much would 3 refills be? So here's what you've got to do. Take $4.85, add that to 65 cents times 3, because this is your refills. This is the first bucket. Okay, you have to buy the bucket first and tell me what this is. Okay, I get, on my calculator, it'll just say 6.8. Hold your horses though. I want this in a sentence form. And this is actually the cost, the money. You typically don't write 6.8 as money. So let's say we're going to say the cost of 3 refills. The cost of 3 refills is, and I'm not going to say 6.8, I'm going to say $6.80. This is the bucket. Then I got 3 refills. Okay, you can't just go get refills if you didn't buy the bucket first. Okie dokie. All right. Last but not least, here's part C. This one says, okay, if you spent $7.45, how many refills did you get? Okay, $7.45. That's what I spent. That has to equal the first bucket at $4.85, and then 65 cents times every refill. And I don't know how many refills there were. Okay, so let's go to town here. First, you got to take off the $4.85 because that's the bucket. Algebraically, it looks like this because that goes to 0. You're thinking out of that $7.45, first take off the bucket, because then you get $2.60 here. That's how much then you spent on all of the refills. Okay, so now figure out how many refills 65 cents gets you to get you up to $2.60. And when you figure that out, you get exactly 4. Hold on. Sentence form. Okay, so how many times did they refill their popcorn? They refilled the popcorn, or their popcorn, 4 times. There we go. All right. If you got through this and you're following along, you've got it, and you'll rock that test tomorrow. All right. Good luck, and may the force be with you.